Good evening, guys. I'm going to do the graph of the derivative of a function because this is one of the things that we couldn't touch on. But as I was explaining on Tuesday, I did explain a bit of there and there about the whole concept of everything. Right, now let's read what they say here. It says the derivative of a function is itself also a function. So meaning when we derive a cubic, we form a parabola like I said, and when we derive a parabola, we form a straight line. The graph of the derivative of a function can be drawn to show how the gradient of the original function changes from point to point. The y value of the graph of the derivative is equal the y value of the graph of the derivative is equal to the gradient of the original function, which is true. Remember that if the original function is f of x, when I do the first derivative of f of x, I'm actually calculating the gradient. So that's what they mean there. Graphs of the function y and its derivative will then be as shown here as an example. So they gave us a parabola. Then after giving us a parabola, they did the first derivative of it. So what is more important for us is the turning point. So the turning point becomes the x-intercept of your graph after you do the first derivative. Understand, but I'll go into detail with it as we go down. But I want you to have what's happening, right? And then good. The derivative of a quadratic function. The derivative of a quadratic function is a linear function. The derivative of a cubic is a quadratic function. Do you understand? So if this is the stationary point, your turning point, like I said, it will be now the x-intercept of your linear function. Do you understand? Yeah. And then if your graph, if it's a concave up, a is greater than 0, also your straight line will be increasing. Do you understand? It will be an increasing graph where a also here is greater than 0. If it's a concave down, my graph will also decrease, and then I know that this point of the turning point will now be the x-intercept of the linear function. Good. And then we know that the graph of the derivative has the x-intercept at the x value where the original function has a stationary point. It means the first derivative has an x-intercept where f has a stationary point. Where it's the turning point, that will be the x-intercept. Good. Let's now go to the derivative of a cubic function. So remember we said that stationary points will then be what? Will be the x-intercepts of the new graph. So the x-intercept, the x-intercept. So we take the x-coordinate. That will be your x-intercept of the new graph. And then the point of inflation, which is the midpoint between these 2 points, will then be the turning point of the parabola. This is when a is greater than 0. This is when a is less than 0. The positive cubic and then a negative cubic. So the stationary points will become the x-intercept of the parabola, and then the point of inflation will be the turning point of the parabola. And then after I can derive this parabola, that stationary point now will become the x-intercept of the linear function. Do you understand the connection between the three? So we move from a cubic, we go to a parabola. From a parabola, we go to a straight line, what I explained there. Same applies as when the graph is negative. The stationary point, which is your turning point, will be your x-intercept of the parabola. The stationary point will then be the x-intercept of your linear function. So I hope you understand what I'm saying. It says to us, note that the graph of derivative has the x-intercept at the x values where the original function has stationary point. Basically, the stationary points are your x-intercept of the graph of the derivative. Also, the graph of derivative has stationary point at the x value where the original function has the point of inflation. So the point of inflation will give us the turning point of the first derivative of a function. Good. Example 32. Draw a rough sketch of the graph of the derivative of each of the following functions. Now I need to draw the rough sketch. Okay, the x coordinate of a parabola will then become what? The y-intercept. My graph is what? It's concave down, so it's a decreasing function. So decreasing function, it's a rough sketch, guys. So we're just interested in the point. So that's where your point will be. It will be the x-intercept of your graph, and your graph must decrease. If it was a concave up graph, let's say maybe the turning point was here at -3, then the graph will then could have been increasing and then 3 there. I hope you understand. Then now the rough sketch of the derivative of this function, it's a cubic, so it's going to be a parabola. We said that the x coordinate of the turning point will be the x-intercept. Increase, decrease, increase, increase, decrease, increase. A is bigger than 0. So this is concave up. So I will have a graph probably like that. Then this will be -1. This will be 2. Then remember, if I want the point of inflation, the x coordinate, I can do the midpoint. So 1 minus 1 plus 2 divided by 2, I will get 1/2. So the point of inflation also, it's at 1/2, which will be the turning point at that point. Let's refresh ourselves, guys. The turning point of our parabola, the turning point of our cubic will be the x-intercept of the parabola. And then the turning point of the parabola will be the x-intercept of a linear function, right? And if I have the x turning points, to get the point of inflation, I just do the midpoint. I get that it's half. So the point of inflation, it's the turning point of the parabola. So that's basically the concept. If you can say this out loud yourself, analyzing the situation, that's only then you'll know that you understand the concept. So take a breather and then just repeat yourself over and over. Okay, this and this is when this and then and that. Yeah, good. I'm going to do example 33. How does this question appear on a test? I'm going to do example 33. And after doing example 33, tomorrow in class, I'm going to give you guys a question that is based on this. Right. The first question says, what is the gradient of the tangent to f at x is equals to 0? We are given the derivative of an original function f that we don't have. And then we said that the derivative of this function, we know when we derive, we're getting the gradient. And the gradient, the first derivative is the gradient of the tangent. So what is the gradient of the tangent? This is already the derivative. The derivative at x equals to 0. So we want f at x is 0. It's how much? When I look at this graph, this is where x equals to 0. So the answer there would be m equals to -4. Because this graph already is the derivative. At 0, x at 0 is -4. So that will be the tangent of your graph, right? The gradient of the tangent. Write down the x coordinate of the stationary points of f. Remember, if this is the graph of the derivative, the x-intercepts are the x coordinate of the original function. So therefore x equals to -3 and x is equals to 1. Number C, what is the x coordinate of the point of inflation of f? Remember the point of inflation of f, if I have the x coordinate of my turning point, I can just get the midpoint. So this will be -3 plus 1 divided by 2, which is -2/2, which is -1. Therefore, x equals to -1. This will be the x coordinate of the stationary point of f. The x coordinate of the point of inflation. The point of inflation It's the midpoint of the x-intercept of your parabola. What is the gradient of the tangent of f at x is equals to minus 2? Number D. At x equals to minus 2. X is minus 2. Okay, we know that this is minus 1. Minus 2, it's minus 2 somewhere there. So if we could use, what is this? By just looking at the graph at minus 2, the gradient could be at minus 4. Do you understand the concept? So I can read it from the graph and say the gradient is negative 4. Or I can get the equation y equals to x minus x1, x minus x2. This is y equals to a, x plus 3, x minus 1. Substitute 1 point where my graph is passing minus 4a, 0 plus 3, 0 minus 1, minus 4 equals to a, negative 3, this is negative 3, negative 3, a equals to 4 over 3. Right. This is a, it means my graph is y equals to 4 over 3, x plus 3, x minus 1, y equals to 4 over 3, x squared, minus x plus 3x minus 3, y equals to 4 over 3, x squared plus 2x minus 3. This is y equals to 4 over 3, x squared, plus 8 over 3x minus 4. So if I were to do, remember this is your first derivative already. This is the first derivative. This is the equation of this graph, and we know that this is the first derivative. This is already my gradient. Are we clear? This is already my gradient. Now it means what I have to do now, I have to do the gradient at that point. At point is x at minus 2. So this is minus 2. It's 4 over 3 minus 2 squared plus 8 over 3 minus 2 minus 4, which is equals to. Let me quickly go and grab my calculator. I'll be back. All right. This is 4 over 3 times. Minus 2 squared. Yeah, I get the answer as negative 4. So this is negative 4. So you see, getting the equation of this and substitute that point together, gradient can take you so long, when you can just, because of the axis of symmetry, just put a straight line where you think minus 2 could be, and the gradient will definitely be at negative 4. We move now. For which values of x is f increasing? The original is increasing, not this one. The original. Where is the original increasing? Now, what I like to do is I check the graph. This is it's concave up, so it's a positive graph. So we know that our graph was probably just going like this. Where this was negative 3 and then this was positive 1. So the graph of f, I know it's increasing up until the turning point and also after the 1. So that's where it's increasing. So the solution for number E will then be x is less or equals to -3, or x is greater or equals to 1. Remember, in cubic we include the stationary points, because at the stationary point the graph is either increasing or decreasing. We want where it's decreasing. Where it's decreasing is that part that is left. It's here. So it is decreasing between -3 less than x, which is less than 1. So that will be the solution. And then is f concave up or down at x equals to 0? At x equals to 0, which is my point of inflation. And how is the gradient there? First derivative of 0 is equals to how much? -4. Now, for us to can know if it's concave up or concave down, it would be very easy. It will be very easy for us to have second derivative at that point 0. Okay. The second derivative at x equals to -4. We can determine second derivative using our equation. Let's check. Second derivative is equals to, this is going to be 8/3x plus 8/3. So at 0 is equals to 8/3, 0 plus 8/3, which is 8/3. Therefore, second derivative is greater than 0. Definitely it is concave up. That will be your answer. Good. Now we move to number F. No, that was number F. Number G, draw a rough sketch of the graph if the second derivative is greater, f of x at 0 is greater than 0. Meaning if x equals to 0, the y will be greater than 0. So it means my graph, we can have a graph. I have 3 points that I can point. I have the coordinates of the turning point. I have the point of inflation. I also have the other one. So my graph can be, to accommodate all the points, can be something like this. Yes? Oh, sharp. Thanks. All right. Sorry about that. So let's do a rough sketch. So I can do a rough sketch. I have point 3 where the graph has to turn. At -3, it's turning. And at 1, it's also turning. But obviously, it has to turn this side. And then they told us this is the x-intercept. This is the y-intercept. At x is 0, it must turn somewhere positive. It must cut somewhere positive as well. So it's cutting somewhere there. So I might have something like this. Yes. And then the point of inflation is somewhere here because it's negative again. So this will be -1, -3, and 1. So this will be the rough sketch of the graph. So they will normally ask for a rough sketch most of the time. Yeah, and I think that will be all. Try to practice this example as I will give you, or the next exercise in our book will be exercise 11, number A, as class activity. The next one I forgot is class activity number mang, and then try to do number B as the next class activity after this one. Try to practice that and then you will be good for tomorrow.